Welcome to the lecture series of data structures. I'm Amrit Kaur and I will be covering the topic bubble sort algorithm. Let us see through the contents. First, I will be discussing about what basically bubble sort is, the entire explanation of the algorithm. Then I will be covering the algorithm with the help of a solved example, and lastly we will be seeing a C program for the same. Let us see what bubble sort sorting algorithm is. It is a very simple algorithm which basically scans the entire list of elements or array from left to right repeatedly. And let us suppose we call each of the scan as a pass. And for every pass, whenever it reaches to a position of a given element, it simply compares it with the adjacent element and swaps it provided the ordering is not correct. With ordering, I basically means it is here to place the elements in the increasing order, and with every scan or with every pass, what happens is the largest element eventually moves to the highest index present in the array, and thereby it gets sorted. So let us see the algorithm first, or the pseudo code for the same. So what we see over here is, this is the condition, that is we have an element selected that is at the first position, and then we compare it with the next element present. For this we have two loops running simultaneously, that is we are selecting the first element. For the first picked element we are traversing it throughout the array list, and while we are traversing it we are comparing it with the element present next to it for a given condition, that is if the current element is greater than the next element we will simply perform a swap. Finally, this is done. Our last element, or we can say the largest element, moves towards the end of the list in the highest index. Let us see the example for the same array comprising of certain integer elements. Now in this, it is grouped into two categories, or we can say it is divided into two categories. First is this unsorted list, which is the complete array, and then comes the sorted list, which is initially empty. For this, what we consider is first element is picked up. Since we are scanning the array from left to right, so first element is picked up, it is compared to the element present next to it or the adjacent position element. If the element 5 over here is greater than the element that is present next to it or adjacent to it, then we simply swap them. As you can see in this case, the element was greater at the jth index and it was swapped with the element present at j plus 1th index. So 1 is swapped with 5. Again, we will increase and move our pointer. Now our pointer points to the first index over here, and we simply compare it with the element present at the next index. So 5 is compared with 4. Since 4 is less than 5, over here we will see that 4 moves at this particular position and 5 moves at this particular position after the swap. So what happens next is, again the pointer moves and increases by a position of 1. Now the pointer points at 5. We will compare it with the element adjacent to it, which is 2. Again, we will check for the if condition. The condition states that if 5 is greater than 2, then we will have to swap it. Which over here is true. 5 is greater than 2, we simply swap it. The element 2 moves over at this particular index, that is the second index. And 5 moves to the index number 3 where 2 was already present. So now we have our pointer increased by a value of 1 and it moves to this particular index, that is index number 3. Now 5 is compared with 8. What happens is, when 5 is compared with 8, again a condition is checked, but in this case we find that 5 is already less than 8. So swapping is not done, we'll simply move a pointer ahead and 8 is compared with 9. Now when we compare 8 with 9, we see again the swapping is not required because 8 is already less than 9. So in this case, swapping is not required, we move towards the end of the position. So finally we have the last element or the highest element, which over here is 9, to be present at the last index of the array, or we can say the highest index of the array, and simply we increase the pointer, or we can simply say we shift the marker of the unsorted array by a position of 1 to mark that this particular element now belongs to the sorted array list and the remaining elements move towards the unsorted array list. Again, we repeat the process for the remaining elements present in the unsorted list. In this case, we start with the first element again. So for this, we have 1 to be the first element. We compare it with the next element present in our unsorted array list. 1 is compared with 4. No swapping is required. It simply moves the pointer ahead. Now 4 is compared with 2. 4 is greater than 2. So definitely swapping is required. So 2 moves to a position of 4, that is the 1th index, and 4 moves towards the position of 2, that is the second index. So as you can see in step number 6, we have the positions of 2 and 4 interchanged after the swap operation. Next, we compare 4 with 5. Now, in this case, swapping is not required. So, we move the pointers ahead. 5 is compared with 8. Again, the swapping is not required as per the condition. So, what happens is we will simply shift the marker of the sorted list with the position ahead, and it simply says now there are 2 elements present in the sorted list and the remaining elements are the part of the unsorted list. In the next pass, what we simply do is we will start comparing the remaining elements present in the sorted list. For the remaining elements present in the sorted list, what we simply do is, again we will start with the element number 1 or the element present in the first index, that is 1. 1 is compared with 2, no swap is required. 2 is compared with 4, again no swap is required. 4 is compared with 5, again no swap is required. What simply happens is we will shift the marker of the sorted array list with the position ahead. Now the elements present in the sorted array list is 5, 8 and 9, and our marker shifts to the position between 4 and 5. Again, for the unsorted array list, that is from 1, 2 and 4, we will start comparing. 1 is compared to 2. Again, no swapping is required since 1 is less than 2. For 2 and 4, again no swapping is required because 2 is less than 4. And since we are already aware that the elements present towards the end of the list are already sorted, so it is not required to go traverse them because no swapping operation is required to be performed. So this is a little bit of improvement that we can do to save upon our time. Next, what we do is we move towards the last pass, that is the pass number 5. Because now 4 also moves towards the end, our marker is shifted. It lies between 2 and 4. So eventually we move towards the next element, that is 1 is compared with 2. No swap is required, and when we reach out to 2, there is no more comparison that is required. So eventually the marker simply moves to this particular position. After the last pass present over here, we have 1 to be as the only element, which does not require neither any comparison also, and nor does it require any sort of swap. So final list is 1, 2, 4, 5, 8 and 9. So this was all about bubble sort. What we saw here is that after every scan or after every pass, the element which is highest element gets bubbled up to the last position of the unsorted array or the highest index value of the unsorted array. And to avoid any further traversals to the sorted list, we simply shift the marker by a position of 1 once a sorted element is added over there. So the complexity evaluates to be big of n squared since there are two nested for loops that are involved for the same. Now let us see the basic C program for the bubble sort algorithm. Initially I have included the header file, that is stdio.h, as you can see over here. Then we will proceed with the creation of main function. Now it can be either void main or end main. Provided I have taken end main, I have to end it necessarily with a return statement, that is in the line number 31 I have taken a return 0 statement. What I have done is I have simply used from this particular step up till this point, what I have done is I have simply made a user to enter an upper limit of the numbers I want to put into my array. Now my array is named as number. I have made all the necessary declarations in the beginning of the program itself. All the looping variables, the temporary variables that I will be requiring for the swap operation, and the count is basically for the number of integers I am willing to enter. Then I have this array named number. So this is going to be used to do the bubble sort algorithm, and my numbers will be arranged in this particular array itself. So now what is happening is I am making the user enter the upper limit of the total numbers that it is required to enter. Then the for loop and the corresponding scan is further used to take the input integers from the user one after the other. Finally comes the main logic. Now this main logic is simply doing, as I have already explained in the program with the help of an example, that now what it is doing is it is taking the number one after the other from the array which is named as number, and then it is comparing the element present at that position with the element present to the next position. That is, it is comparing the two adjacent elements that is situated at j and j plus 1 at index. On the basis of the operator, that is the comparison operator that I have put over here, it will simply rearrange the array elements that the user has initially entered by using a swap call. Now using these particular steps in the line number 20, 21 and 22, it will simply swap the values of the adjacent integers in the array if it is required as per the condition. Finally, after the condition is over, what we can see over here is we are simply printing the sorted set of elements that are being rearranged in the order dictated by this comparison operator. So this is all about how I have represented it. It is similar to the pseudocode and quite easy to understand. The main function is of that of the logic that we have applied and the order in which we want to arrange our elements. Let us first compile the program. So this is what my program looks like. It is asking me to enter the number, basically the upper limit. My array was up to number 30, so I can enter as many integers as I want. Say for example, I am willing to enter 10 integers. Now I will keep on entering one number. Now these are my sorted list of elements. The time that is required, it has returned it. It has arranged all the elements that are present in the array. So this was all about the bubble sort algorithm. I hope now the entire implementation is clear based on how to apply the algorithm, how the algorithm basically works like, which has been clearly depicted in the example. And this is a similar explanation for the same. This was all about the bubble sort algorithm, an example and an implementation. Here are the few references. Thank you.